Hi, welcome back to the channel. Today we're going to use AWS CDK to create a Fargate scheduler. Okay, let's jump straight into a new project. And the first thing we're going to do is open a terminal and we're going to type CDK init app, and the language we're going to use is going to be TypeScript. That's going to go away and create the project structure for us. Now that's done, one of the first things I like to do is I'll go into the bin folder and click on this Fargate scheduler TS file. And I'm just going to comment back in this line here just so it picks up my default CDK account and region. I'm going to hit save on that. We can now close that file. And then we're going to go to lib and we're going to open up the stack that it is created for us. Now this is some template code that we can get rid of straight away. Now first off, we're going to import DynamoDB. We're going to use DynamoDB for the scheduler container to actually write to an external service some data. So for this, nice and easy, we're going to actually import AWS underscore DynamoDB as DynamoDB. And that's going to be from the AWS CDK lib. So now we've got that import, we can actually go and declare in the stack our DynamoDB table. This is going to be our DynamoDB table. So this is going to be a const Dynamo, let's just call it Dynamo table. And that's going to be a new, and it's going to be our new DynamoDB dot table. It's going to have the construct is going to be this construct, this. And for now, let's keep it simple. So we'll just name it ID Dynamo table. And we're going to pass a couple of parameters into this table for setting it up. So first off, we're going to have our partition key. Let's go. The name for our partition key is going to be ID. And that's going to be a type string. Next up, we're going to just set the billing mode. The billing mode we're going to use is going to be DynamoDB dot billing mode dot, and we're just going to do pay per request. Also, as this is just an example stack, we're going to add a removal policy of destroying. Not something you would typically do in production. So the removal policy is going to be to destroy. And that's the DynamoDB table created. Next up, we're going to have to create a VPC. So this is our VPC. So for this, we're going to have to add another import for importing VPC. And VPC is found in the EC2 service. So let's go and add AWS underscore EC2 as EC2. I always like to shorten these, makes them a bit easier to read. So we're going to say our const VPC is equal to a new EC2 dot VPC, and again construct is going to be this. The name, let's go with just my VPC, and the parameters, we can add some parameters if we want. So maximum availability zones 2. Now we have the VPC created. What we can actually do is we need to add the DynamoDB table into the VPC. And that's done by using a gateway endpoint in VPC. So we're going to say, again, const Dynamo gateway endpoint is equal to our VPC dot, and there's a function here called add gateway endpoint. We're going to name this ID. We give it a name. Let's go with Dynamo gateway endpoint. And the parameters we're going to give it are going to be the service, and that's going to be ec2.gateway VPC endpoint AWS service dot DynamoDB. That will open up our VPC so it can connect through to the DynamoDB table. Next, we're going to create a cluster inside our VPC. For this, we're going to actually have to add another import. So we're going to want to add ECS as ECS. We can come back down to here and we're going to say, okay, our cluster. This is going to be const cluster is equal to a new ECS dot cluster. It's going to be this, and let's just name it something simple again, my cluster. And the VPC for the cluster is, we named nice and simply VPC. Okay, for this next part, we're actually going to create another directory, or a couple of directories, inside our project. So we're going to create one called containers. And inside containers, let's create our actual container code, and that's going to be called our test. Let's go test scheduler. Now we can actually make the container image for that directory. The files won't exist in the directory yet. We'll add them shortly, but let's finish creating the stack first. So we're going to say const container image is equal to ECS dot container image, and that's dot from an asset, and we're going to use the path function. So path dot join, and it's going to be underscore directory name, comma, and it's going to be upper directory from where we are, containers / test scheduler. And that is our container image. Now we will need to import the path library. So we're going to go import, and we're going to import path, and that's going to be require path. Whilst we're here, we can also import our ECS patterns that we're going to use next. So that's AWS underscore ECS patterns, and that's going to import as just ECS underscore pattern. Now we can also add another library. This is going to be our AWS underscore application auto scaling, and we can import that as let's go with app underscore scaling. Now this is where we're actually going to create our Fargate task. So Fargate task, if you don't know, it essentially will spin up a container, run that container as a task, and then once completed it will close back down. Similar to a Lambda function, but typically used for slightly bigger tasks. I tend to use them if anything takes more than between 5 to 10 minutes. So we're going to say here we're going to have our create Fargate. So we're going to say const Fargate is equal to new, and this is where we're going to use that ECS patterns dot Fargate of scheduled Fargate task, and again it's going to be this, and the ID, keeping it simple, scheduled Fargate task. And now we can add the properties. So the first property we're going to add is going to be the cluster. That's going to be cluster. Then we can add the scheduled Fargate definition options. No, we're going to add, in fact, let's add the image options. So the image is going to be the image we just made. So that is our container image. Then we have the memory limit. And let's go with nice and small, 512. And then we've also got the environment. So for the environment, I'm going to actually create two things to pass in. We're going to have a Dynamo table, which is going to be our Dynamo table dot the table name. I'm also going to pass in the region that we're building this in, and that can be passed in from process.env, and this is our CDK underscore default underscore region. Next up, we can add in the schedule. So the schedule, this is where we're going to use that app auto scaling that we set up. So app auto scaling dot schedule, and we're going to use an expression to create the schedule. And I'm going to go with something quite simple to start with. We're going to say rate 1 minute. That means that the Fargate task will trigger every minute. And finally, let's just declare the platform version as ECS dot Fargate platform version dot the latest. Now we have the Fargate task. All we need to do now to finish the stack off is give the Fargate task permission to actually write to the DynamoDB table. So what we're going to do first off is we're going to give the permission to with the Dynamo Gateway endpoint. So let's just add permissions. So Dynamo Gateway endpoint dot add to policy, and for this we're going to actually need a new IAM dot policy statement, and we haven't actually imported IAM yet, so let's just fly up to the top, add AWS underscore IAM as IAM. So we should pick up IAM dot policy statement, and the effect that we want is to IAM dot effect dot allow. Principles are going to be a new IAM dot any principle, and the action is going to be, we're going to say DynamoDB put item. Now we want to make sure this works on our resource, so our resources are going to be, let's just add in our Dynamo table dot table ARN, and we're going to then add also a condition. This is going to be our task definition role ARN. That's our adding to our policy, and then we will also just give DynamoDB table dot grant write access to our Fargate dot task definition dot task role, and that should be our stack created. Hopefully there's not any errors in there. The next we need to actually make the Docker container that is going to be loaded into the Fargate. So I'm not going to go into too much detail into here. So I've added all the code for the container. I'm just going to run through that quickly with you. So we have the Docker file. The Docker file is just going to be a node Docker file, working directories user. It's going to do an npm install and an npm build. and the main command is just going to run this index.js file with Node. So package.json, quite simple as well. We've got our build command. That's the main one we need for this. We also have the dependencies of the AWS SDK, because we're going to use the SDK to actually access the Docker functions. The TypeScript config file is a fairly standard TypeScript config file. And then finally, if we actually go and look in the index.ts file, so this is the container code that will actually run. Again, it's quite simple. It's going to create a new document client for DynamoDB on the database table that we actually passed in as the environment variable to the container. And we're going to, the parameter is going to be a new ID, which is just going to be a random number. And we'll actually do a put on the DynamoDB table. And that is all it's going to do. It's just going to, every time the container starts up, it's going to put a new random number into the DynamoDB table. Okay, now we have all of the code in place for the container. We should actually be able to build the project. So we're going to type npm run build. Now that's built all the code, that hasn't errored out, that's compiled all the code, should I say. And the next thing we're going to type is we're going to type CDK synth, and this is going to synthesize our code. Okay, now we can type CDK deploy, and we're just going to say star, because there's only one stack in here anyway. So this will actually show you the permissions that are going to change. So obviously they're new permissions, so everything will be set. So we can just say yes. And there we go. So the stack has actually deployed fully. So if we go into the AWS console, go to DynamoDB and down to tables, we can now see our actual Fargate scheduler stack DynamoDB table. And in here we can click explore the table items. And at the moment, we haven't got any items in there yet. If we wait a minute, hopefully one will appear. And there we go. We've got an item in the table. Just a random number that's been generated and added to our table. So there we go. We've got our scheduler running. If we leave this running a bit longer, we'd get a whole bunch more numbers. So if I hit refresh again, it's been a little while now. So there we go. Look, we've got loads of items in the table. So if we go back to the stack, we can just finally, just to finish off, clear everything up. We can type CDK destroy, hit enter, and that will actually take our stack back down. Press yes. There we have it. The stack has been taken back down, and it's all complete. So thanks for watching. If you found this useful, consider subscribing and check out some of the other videos. If you do need any of the code, in the description will be the GitHub repository where you can find all these examples and links to the blog posts that go along with them as well. Thanks for watching.